Welcome to this e-learning module on information technology in logistics and supply chain management. In today's supply chains, products don't move efficiently unless information moves even faster. Across this chapter, we'll look at how digital systems have become the nervous system of logistics, connecting planning with execution and linking suppliers, warehouses, carriers, and customers through accurate, timely data. Here's what we'll cover. First, we'll clarify the role of IT in logistics and why it is central to performance, visibility, and customer experience. Then, we'll walk through the major systems used in practice: enterprise resource planning, warehouse management systems, and transportation management systems. Finally, we'll explore emerging technologies like IoT, AI, blockchain, robotics, cloud, and advanced analytics, and how they are reshaping logistics operations. Let's begin with the big picture. It is the enabler of modern supply chain operations. Logistics is a high-speed coordination problem. Inventory must be accurate, orders must be fulfilled correctly, shipments must be optimized, and exceptions must be handled instantly. It makes this coordination possible by capturing data, sharing it across partners, and turning it into decisions at scale. Why is IT so important in logistics? First, it creates real-time visibility, knowing where inventory is, where shipments are, and what is likely to happen next. Second, it drives automation and efficiency by replacing manual steps with standardized digital workflows. Third, it enables data-driven decisions, from forecasting demand to choosing carriers. Fourth, it enhances collaboration by connecting internal teams and external partners on shared information. Fifth, it reduces costs through better planning and fewer errors. And finally, it improves customer service by providing accurate promises, proactive updates, and faster issue resolution. In practice, IT supports a wide set of logistics activities. It helps optimize inventory by tracking stock levels and movements and supporting replenishment decisions. It supports order processing by validating orders, allocating inventory, and coordinating fulfillment. It enables transportation planning and execution, choosing routes, modes, and carriers, and tracking deliveries. It manages warehouse operations like receiving, put away, picking, packing, and shipping. It strengthens demand forecasting and planning through analytics, and it improves supplier collaboration by standardizing communications, sharing forecasts, and monitoring performance. When these applications work well, the benefits are significant. Operational efficiency improves because work is organized around better information and fewer manual handoffs. Accuracy increases, meaning fewer picking errors, fewer shipment mistakes, and more reliable inventory records. Resources such as labor, space, and transportation capacity are used more effectively. Response times improve because exceptions are detected earlier and decisions can be made faster. Over time, this becomes a competitive advantage. Companies can deliver more reliably, at lower cost, and with greater flexibility. And importantly, strong IT foundations allow scalability, supporting growth without the same growth in complexity. However, none of this is automatic. IT also brings challenges. Implementation can be expensive, especially for enterprise-wide platforms. Integration is complex because supply chains involve many systems, partners, and data formats. Change management is essential. New systems often require new processes, and people may resist. Data security becomes critical because sensitive operational and customer information is shared across networks. Maintenance is ongoing. Systems need updates, monitoring, and continuous improvement. And finally, modern logistics requires new skills, from analytics literacy to system configuration and cybersecurity awareness. Now, let's focus on ERP systems. ERP, Enterprise Resource Planning, refers to integrated systems that manage core business processes across an organization. In logistics terms, ERP often serves as the central system of record. Orders, inventory values, suppliers, customers, financial postings, and planning signals typically flow through the ERP backbone. An ERP is an enterprise-wide platform that integrates major functions such as finance and accounting, human resources, manufacturing operations, supply chain management, customer relationship management, and business intelligence. The key idea is integration. Rather than each department maintaining separate data and processes, the organization works from a shared, consistent dataset, so decisions are made with one version of the truth. ERP platforms are usually organized into modules. Financial management handles accounting, billing, and cost tracking. Supply chain management supports purchasing, planning, and inventory. Manufacturing modules connect production planning and execution. Human capital management supports workforce administration. CRM manages customer-related processes. Project management supports complex initiatives and rollouts. And business intelligence layers reporting and analytics on top of all of this, so leaders can monitor performance and investigate root causes. The benefits of ERP begin with process integration across departments. Sales, procurement, operations, and finance can coordinate without delays and duplicate work. Data becomes centralized and consistent, improving trust in reports and reducing reconciliation efforts. Operational efficiency improves through standardized workflows and automation. Decision-making gets better because data is available in near real time, not weeks later. ERP also encourages standardization, important for quality and control, especially in multi-site operations. And as organizations expand, ERP can scale to support new products, regions, currencies, and reporting needs. ERP implementation typically follows a phased approach. It starts with planning and requirements, defining what the business needs and what success looks like. Then comes design and configuration, where processes are mapped and the system is set up. Testing and validation follow, ensuring transactions work end to end. Training and change management are critical, because users must adopt new ways of working. Then comes go live and support, when real transactions begin. Finally, continuous improvement ensures the system evolves with the business, because ERP is not a one-time project, it's an operational capability. ERP also has well-known challenges. Costs can be high, including software, consulting, data work, and training. Deployment can be complex and lengthy, especially if many sites and processes are involved. Change resistance may appear because roles and routines change. Organizations often face a key tension: customization versus standardization. Too much customization increases complexity. Too much standardization may not fit the business. Data migration is another major hurdle, moving clean, correct master data and transaction history into the new system. And after go live, maintenance and upgrades continue, requiring ongoing ownership and governance. Selecting an ERP should start with alignment to business requirements. What problems must be solved and what processes must be supported. Industry-specific functionality matters because logistics and manufacturing needs differ from service industries. Scalability and flexibility are important for growth and change. Integration capabilities are essential. ERP must connect to WMS, TMS, supplier systems, and customer platforms through APIs or standard interfaces. Vendor reputation and support matter because ERP is long-term. Total cost of ownership should include implementation, licenses, upgrades, and internal effort. Next, we move into warehouse management systems, or WMS. If ERP is the enterprise backbone, WMS is the execution engine inside the warehouse. It manages the detailed operational tasks required to receive goods, store them efficiently, pick orders accurately, pack them correctly, and ship them on time, while tracking every movement with precision. A WMS is a comprehensive system that manages warehouse operations from receiving to shipping. It supports core functions such as inventory management, knowing what you have and where it is, order fulfillment, coordinating picking and packing, labor management, assigning work and measuring productivity, and yard management, coordinating trailers, dock doors, and inbound and outbound flows. Key WMS capabilities begin with real-time inventory tracking, often down to bin, pallet, lot, or serial number level. It optimizes receiving and put away, so goods are stored in the best location based on rules like velocity, size, or handling requirements. It improves picking through pick path optimization, reducing walking time and congestion. It manages packing and shipping workflows to reduce errors and ensure compliance. Labor management tools help balance workload and monitor performance. Reporting and analytics reveal bottlenecks and improvement opportunities. And modern WMS often integrates with automation, such as conveyors, sorters, scanners, robots, and voice or light-guided picking. In receiving, the WMS can process advanced shipping notices, so the warehouse knows what is arriving before it arrives. It supports receipt verification and inspection to confirm quantities and condition. It can trigger quality control checks when needed. It optimizes put-away by recommending the best storage location. It coordinates cross-docking when items should move directly from receiving to shipping. It prints and applies labels to ensure items can be tracked throughout the facility and the broader supply chain. In storage, WMS capabilities include slotting optimization, placing high-movement items in convenient locations, and balancing space usage. It maintains precise inventory location tracking, so the system knows exactly where each unit is stored. It manages cycle counting to maintain accuracy without full shutdowns for physical inventory. It supports stock rotation such as FIFO or LIFO, critical for freshness and compliance. Replenishment can be automated so pick locations stay stocked, and space utilization analysis helps improve layout decisions and reduce overcrowding. Picking is often the most labor-intensive warehouse activity, so WMS plays a major role here. It supports order wave planning to group orders efficiently by route, carrier cutoff, or priority. Pick path optimization reduces travel time. Zone picking coordinates work across different warehouse areas. Batch picking groups similar orders to increase speed. The system can integrate with pick-to-light or voice picking to guide workers hands-free and reduce errors. And pick accuracy verification through scanning, weight checks, or confirmations helps ensure the correct item and quantity are selected. In shipping, WMS supports packing optimization, ensuring the right packaging and the right contents. It helps coordinate carrier selection and scheduling, often in connection with a TMS. Shipping label generation ensures compliance with carrier and customer requirements. Load planning and optimization improve trailer utilization and reduce damage risk. Shipment tracking begins here as shipments are confirmed and information is shared downstream. Documentation management supports packing slips, bills of lading, and regulatory documents, reducing delays and disputes. The benefits of WMS are measurable. Inventory accuracy can exceed 99% when processes are well designed and scanning discipline is strong. Productivity often rises significantly, commonly in the range of 20 to 40%, because travel and rework are reduced. Space is used more efficiently through slotting and better layout decisions. Visibility and control improve through real-time monitoring of work and inventory. Operational costs decrease due to fewer errors, fewer urgent shipments, and better labor utilization. And customer satisfaction improves because orders are shipped accurately and on time, with fewer returns and complaints. Implementing a WMS also follows structured steps. Requirements analysis defines operational needs like lot tracking, temperature control, or automation integration. System selection identifies the best fit. Configuration and customization adapt workflows and rules. Data migration ensures item masters, locations, and inventory balances are accurate. Integration with existing systems, especially ERP, TMS, and automation controls, is a major workstream. Testing validates end-to-end processes under realistic conditions. Training prepares warehouse teams for new workflows and devices. Then go-live begins, supported by hypercare and continuous process tuning. Now let's turn to Transportation Management Systems, or TMS. While WMS optimizes what happens inside the warehouse, TMS optimizes what happens on the road, in the air, at sea, and across networks of carriers and customers. Transportation is often one of the highest logistics cost components, and TMS provides the tools to manage it strategically and operationally. A TMS is a comprehensive platform for planning, executing, and optimizing transportation operations. It typically supports inbound transportation, bringing materials from suppliers, outbound transportation, delivering products to customers, freight payment, ensuring invoices match agreements, and performance analytics, tracking costs, service levels, and carrier performance. In planning, TMS supports route planning and optimization to reduce distance, time, and cost while meeting delivery windows. It enables load consolidation, combining shipments to increase utilization. It supports carrier selection based on cost, service, capacity, and constraints. Mode optimization helps decide between truck, rail, air, or sea depending on urgency and cost. Network design capabilities help evaluate distribution structures over time, and scenario analysis allows planners to test what-if situations like fuel price changes, new warehouses, or service level targets. In execution, the TMS manages order and shipment workflows. Shipment tendering sends loads to carriers and manages acceptance. Track and Trace provides shipment status updates, often in real time through GPS and carrier integrations. Appointment scheduling coordinates pickups and deliveries. Dock scheduling helps facilities manage capacity and reduce congestion. Real-time visibility improves exception management, so teams can respond quickly when something goes wrong rather than discovering it after the fact. In settlement, TMS supports freight audit and payment, verifying that carrier invoices match contracted rates, accessorials, and actual shipments. It performs invoice matching and validation to prevent overpayment. Accrual management supports financial accuracy by estimating transportation spend. Cost allocation assigns freight costs to products, customers, or business units. Carrier performance tracking supports strategic sourcing decisions, and claims management helps handle damage, loss, or service failures more efficiently. Transportation analytics turn operational data into insight. Cost analysis and reporting show where money is spent and why. Carrier performance metrics quantify service levels, claims, and responsiveness. On-time delivery tracking supports customer service and continuous improvement. Freight spend analysis supports negotiations and network strategy. KPI dashboards provide ongoing operational control. And predictive analytics can anticipate delays, identify high-risk lanes, and recommend proactive actions. The benefits of TMS include transportation cost reduction, often estimated around 5 to 15%, through better planning, consolidation, and auditing. Efficiency and productivity improve as workflows become standardized and automated. Visibility and control increase through real-time tracking and exception management. Carrier relationships improve because expectations, performance, and communication become clearer. Decisions become more data-driven, supporting both operational and strategic improvements. And customer service improves with better delivery performance and more accurate shipment updates. For TMS implementation, a few considerations are critical. Integration with ERP and WMS ensures orders, inventory, and shipment confirmations align across systems. Data quality and cleansing matter. Incorrect addresses, weights, dimensions, or rate tables will undermine optimization. Carrier onboarding is essential because value depends on connectivity and compliance. User training ensures planners and customer service teams can use the system effectively. Change management aligns processes and responsibilities, and a phased rollout by region, mode, or business unit reduces risk while building confidence. With the foundations of ERP, WMS, and TMS in place, we can explore emerging technologies. These innovations are transforming logistics by increasing connectivity, intelligence, automation, and responsiveness. The key shift is that supply chains are moving from periodic planning to continuous real-time decision-making. The Internet of Things, or IoT, enables connectivity through sensors and devices that generate data automatically. In logistics, IoT supports real-time asset tracking for vehicles, containers, and high-value goods. It enables condition monitoring, such as temperature and humidity in cold chains. It supports predictive maintenance by identifying early signs of equipment failure. Fleet management becomes smarter through connected vehicles. Overall supply chain visibility improves because events are captured directly from the physical world. And in smart warehouses, IoT helps connect equipment, workers, and inventory into a coordinated system. Common IoT applications include GPS tracking devices for location and route compliance. RFID tags and readers support fast, non-line-of-sight identification and inventory checks. Temperature sensors protect pharmaceuticals and food. Vibration monitors detect handling issues and equipment wear. Smart pallets and containers can report location and condition. Connected vehicles provide telematics and driver behavior data. Together, these tools reduce uncertainty and allow faster responses to exceptions. Artificial intelligence and machine learning are transforming logistics from rule-based planning to learning-based optimization. AI improves demand forecasting by recognizing patterns and external influences. It enhances route optimization by considering real-time traffic, constraints, and service priorities. Predictive analytics anticipate disruptions before they happen. Chatbots and virtual assistants can answer shipment status questions and reduce workload. Automated decision-making helps prioritize orders, allocate inventory, and respond to delays. And computer vision supports quality control by detecting damages, counting items, or verifying labels. Practical AI use cases include demand prediction and planning to reduce stockouts and excess inventory. Dynamic pricing optimization can adjust shipping options or service levels based on capacity and demand. Warehouse robot coordination uses AI to manage fleets of robots and avoid congestion. Predictive maintenance reduces downtime of conveyors, forklifts, or vehicles. Fraud detection helps identify unusual transactions or claims. Customer service automation speeds up responses and improves consistency, especially for high-volume inquiries. Blockchain is a distributed ledger technology designed to increase transparency and trust among multiple parties. In supply chains, it supports traceability, tracking products and events across organizations without relying on a single owner of the data. Smart contracts can automate rules like payments upon delivery confirmation. Blockchain can strengthen authentication and provenance, helping prove origin and reduce counterfeits. It can reduce fraud through tamper-resistant records. Documentation can be streamlined by sharing a trusted digital trail across partners, improving trust and reducing disputes. Blockchain applications include product traceability and authenticity, especially valuable for food, luxury goods, and pharmaceuticals. It can support automated payments and settlements based on agreed triggers. Customs and trade documentation can become more transparent and efficient. Supplier verification is improved through shared compliance records. Cold chain monitoring can be strengthened when condition data is recorded and shared. And recall management becomes faster and more precise, limiting cost and protecting consumers. Robotics and physical automation are changing how logistics work gets done. In warehouses, picking robots and autonomous mobile robots support item movement and picking tasks. Automated guided vehicles can transport pallets safely and consistently. Autonomous vehicles and trucks are developing toward reducing transportation constraints. Drone delivery is being tested for specific use cases where speed and access matter. Collaborative robots, or cobots, work alongside humans to boost productivity. Overall, automation aims to increase throughput and reliability while improving safety. The benefits include higher productivity and throughput, because machines can operate continuously and follow optimized routines. Accuracy improves through consistent execution and sensor-based verification. 24/7 operations become possible without the same labor constraints. Safety improves by reducing heavy lifting and risky movements. Labor costs can be reduced or reallocated toward higher-value tasks. And scalability increases. Operations can expand by adding modular automation capacity rather than redesigning everything. Cloud computing has become a major delivery model for logistics systems. Cloud-based solutions provide scalability and flexibility. Resources can grow or shrink with demand. They improve cost efficiency by shifting spending from large upfront capital investments to operational expenses. Cloud access from anywhere supports distributed teams and global operations. Collaboration improves because partners can connect more easily. Automatic updates reduce the burden of upgrades. And disaster recovery is stronger because systems and data can be replicated across secure locations. There are several cloud deployment models. Public cloud uses shared infrastructure and is often cost-effective and scalable. Private cloud uses dedicated infrastructure and can support strict security or compliance needs. Hybrid cloud combines both, keeping sensitive workloads private while leveraging public cloud for flexibility. Multi-cloud uses multiple providers to reduce dependency and increase resilience. The right choice depends on security requirements, regulatory compliance, integration complexity, and cost strategy. Big data and analytics focus on turning large volumes of logistics data into insight and action. Predictive analytics helps anticipate demand, delays, and failures, Real-time dashboards provide operational control for warehouses and transportation. Pattern recognition identifies recurring bottlenecks, seasonal effects, or performance drivers. Performance optimization uses data to continuously improve service levels and cost. Strategic planning becomes more evidence-based, supporting network design and capacity decisions. And customer insights improve when logistics data is combined with sales and service data. Analytics can be applied in many areas: demand forecasting and planning to align supply with expected sales, route and network optimization to reduce cost while maintaining service, inventory optimization to balance availability with carrying cost, supplier performance analysis to improve reliability and terms, customer segmentation to tailor service strategies, and risk assessment to identify vulnerabilities and prepare mitigation plans. Digital twins are virtual replicas of physical assets or processes, like a warehouse, a transportation network, or even a piece of equipment. They enable simulation and testing without disrupting real operations. Predictive maintenance improves by simulating wear and failure patterns. Process optimization becomes faster because alternatives can be tried virtually. Scenario planning supports decisions such as adding a new distribution center or changing order profiles. Digital twins can also support training and development by providing realistic environments. And design validation ensures new layouts or automation investments will perform as expected before committing capital. Augmented reality enhances operations by placing digital guidance into the worker's field of view. In picking, AR can direct workers to the correct location and confirm the right item. For training and onboarding, AR can reduce learning time by guiding tasks step by step. In maintenance and repair, AR can display instructions and diagnostics while keeping hands free. Quality inspection can be improved by highlighting checkpoints and tolerances. Layout planning can be supported by visualizing changes in the real space. Remote assistance becomes possible when experts can see what the operator sees and provide guidance instantly. 5G connectivity supports many of these technologies by improving speed and reliability. It enables ultra-fast data transfer and low-latency communication, which matters for real-time tracking and control. Massive device connectivity supports large-scale IoT deployments in warehouses, yards, and fleets. Enhanced IoT capabilities lead to richer, more frequent sensor updates. Real-time tracking becomes smoother and more accurate, and autonomous vehicle support improves because low latency is critical for safety and navigation decisions. As organizations adopt more technology, integration becomes the key success factor. System compatibility must be checked early, especially when combining ERP, WMS, TMS, and visibility platforms. Data standards and APIs enable consistent information exchange. Security and privacy must be designed in from the beginning, not added later. Change management ensures people actually use the new capabilities. Scalability matters because pilot success must translate into enterprise value. And total cost of ownership must be understood, including licenses, integration, support, upgrades, and the internal effort to sustain the system. A practical adoption strategy usually follows 7 steps. First, assess the current state, systems, processes, skills, and pain points. Second, define objectives and requirements, what outcomes are needed, and how they will be measured. Third, evaluate technology options with attention to fit, integration, and long-term support. Fourth, develop an implementation roadmap that sequences initiatives logically. Fifth, pilot and test to validate value and uncover issues early. Sixth, scale and optimize across sites and partners. And seventh, commit to continuous improvement, because supply chains and technologies evolve constantly. As logistics becomes more digital, cybersecurity becomes a core operational requirement. Protecting digital assets includes securing networks, devices, and cloud environments. Data encryption helps protect information in transit and at rest. Access controls ensure only authorized users can see or change sensitive data. Threat detection helps identify abnormal activity before damage occurs. Incident response planning ensures the organization can act quickly when problems happen. And compliance management supports regulatory requirements and customer expectations, especially when personal data, financial data, or regulated product data is involved.